In this question we are given the region R, which is enclosed by the two graphs of function g of x and h of x. And the vertical axis y-axis and line x equal to 2. And so we need to find the area of R. And so first let's figure out whether it's g of x or h of x is the function which is above. And the way I would do it, I would just plug in the value of x, which is easy to calculate, into one of the functions. And in this case, it's easy for me to plug in x equal to 1. This cancels out, and I know that h of x at 1 has a value of 6. And so at 1 it has a value of 6. So this immediately tells me that this is h of x and that this function is g of x. So then I can write an area of R. So R is equal to integral from 0 to 2 of the function which is above, h of x minus g of x dx. And so plugging in all these values and integrating gives me integral from 0 to 2, 6 minus 2 x minus 1 squared minus negative 2 plus 3 cosine 5 over 2x dx. And this is equal to, continue integrating here, we get 6x minus 2x minus 1 cubed over 3 minus negative 2x plus 3 times integral from cosine is sine times 2 over pi sine pi over 2x, and this is evaluated at 0 and 2. And so this is equal to, we can now plug in 6, this is equal to 6 times 2 minus 2 times 1 cubed over 3 minus negative 4 plus 6 over pi, sine at pi is 0, so times 0, and then from this we subtract, plugging in 0. This is equal to 6 times 0 minus 2 times negative 1 cubed over 3 minus, here is 0, plus 0. So simplifying all this is just an arithmetic, gives us the answer 44 over 3, and I leave this up to you to do the arithmetic. In this question we are given that this region is a base of a solid, and for this solid at each x the cross section of perpendicular to the x-axis has this area. We don't know exactly how the solid is, what it forms, but this is the area if we cross section it according to for each x. And so find the volume of the solid. It's just integral from 0 to 2 a of x dx. And so this is equal to integral from 0 to 2 1 over x plus 3 dx, which is equal to ln x plus 3 absolute value from 0 to 2, and we plug in values, will be ln of 5 minus ln of 3. We can leave it as this expression, or this is ln of 5 over 3. So this is our final answer. In this part of the question, we need to write but don't evaluate an integral expression that gives the volume of a solid generated when this region R rotated about the horizontal line y equals 6. And so where is this line? This line is here, and so then this region is rotated about it like this. So this is the small radius R1, and this is the bigger radius R2. So then this volume is given by the following function. This volume is given by the pi integral of R2 as a function of x squared minus R1 as a function of x squared dx from 0 to 2. And so then what is R2? R2 is 6 minus the function g, which is the function we had here. Remember, we had this as g of x, and this function here is f of x. And then R1 is the difference between 6 minus f of x. So this is equal to pi integral from 0 to 2. And then we have 6 minus g of x squared minus 6 minus h of x squared, and this is all integrated by dx. If you'd like, you can plug in instead of g of x and h of x their expressions, but this is our final answer. Thank you, and I will see you in the next video.